And now we are live. Good evening, everyone, and welcome to another Swift Cairo Live webinar. We are thrilled to have us tonight, whether you are joining from Cairo, across the MENA region, or anywhere around the world. Thank you so much for being here. I'm Mohammed Elnaggar, iOS engineer and co-founder of Swift Cairo. I will be your host for tonight's session. If you have attending our event before, you know our goal is always the same: to build a community and share knowledge and grow together as iOS developers. Tonight's session is a special one. It's really excited. We are diving into topics that are crucial for building robust and maintainable iOS applications: dependency injection. Uh, Before we begin, I'd like to give a special shout out to Ahmed Hassan for reaching out and connecting us with Dan. Thank you so much, Ahmed, for helping this session happen. I know we take much time to have this.
Oh, good.
And yeah, we have honor to joining by Dan, founding engineer at Portola and formerly with Apple, Square, Airbnb. Dan brings a wealth of experience in building scalable, efficient software systems, and we are very lucky to have him with us today. He will be presenting a talk. It's titled Dependency Injection, Done Right, Simple, and Compile Time Safe, DI in Swift. And we will have a QA session at the end, so feel free to drop your question and in the chat through the presentation, and we will have it. Dan, we are really exciting to have you, and welcome to Swift Cairo. And yeah, the floor is yours.
Absolutely. It's great to be here. Give me one moment to set up my screen share here and we will dive right in. So there we go. All right, before I get going, everybody can see what I'm presenting? All right.
Yes, you can see it.
Incredible. All right, here we go. Good evening, folks. My name is Dan Federman. I'm a founding engineer at Portola AI. We're a seed stage company building a friend and assistant that uses generative AI. Today, we're going to be talking about dependency injection. So if you're familiar with the dependency injection space, you're likely familiar with one of the many Swift dependency injection libraries out there. We've got Factory, Swift Dependencies, Needle, Weaver, Swinject, and many more. But those are, generally speaking, the most popular. It's a crowded space. However, I do promise that SafeDI's offering is differentiated. It's both simpler and more powerful than the repos I just mentioned. If you're thinking that maybe an engineer at a seed stage company can't possibly build a tool that'll work well for code bases of the size that you work in, well, trust that I know what it takes to scale large-scale applications. I'm the author of the tooling that Airbnb uses for automated dependency injection, and this tool does it a little bit better. I learned a lot from my time at Airbnb and from building their tooling. And today I'm bringing you a library that takes the hard-won lessons from that time to deliver a simple and safe dependency injection framework with all the functionality that you need as your application scales. It's called SafeDI. SafeDI takes the core concepts of manual dependency injection and automates away all the annoying work. We've got compile time safety, thread safety, hierarchical dependency scoping. This is a big one. We'll explain more what that means later, I promise. Multi-module support, dependency inversion support, cycle detection, generated member-wise initializers for easy testing and maintenance, and very clear human-readable error messages because no one wants to debug generated code. So that's a lot of buzzwords. Folk who know about dependency injection inside and out likely understand the significance here. But for the rest of us, I'm going to explain this all, I promise. Let's zoom all the way out. Before I dive into the specifics of the SafeDI library, I want to walk through why we even care about dependency injection to begin with. Why are we even talking about this, right? So there's a simple truth. Dependency injection is hard, but not at first. All right, let's look at a very simple two-screen application. In this application, we've got a view that logs the customer in and another one that shows the customer their information once they are logged in. Both screens take a user service, an observable object that vends a published optional property. The logged in view has a non-optional user injected in as well. If we have a user, we inject it into the user service, or inject it from the user service into the logged in view directly, and we display it, right, in that first if statement. Otherwise, we show the log in view and inject the user service so that we can log in. Looking at this code, it's pretty simple. We've got simplicity, compile time safety, hierarchical dependency scoping, that user is hierarchical and only there when we have one, and it's not optional, right? And we have constructor injection, right? We're logging this, or we're inserting all of this into the initializer so that it's easy and clear to test if we need to, say, override with a mock user or a mock user service. But then the app gets a little bigger and things start getting a little bit more complicated. So now let's look at the logged in side of the app, which has multiple features. Some of these features are also shared between the logged in and logged out sides of the application. So let's say after building these features, feature E all the way down at the bottom right needs to get a user from the logged in view. If we continue the same pattern that we described in our two view application, we continue to have compile time safety and thread safety and constructor injection. Everything's great, right? But this is a little painful, right? Let's talk about the steps required to get there. So we're going to add a dependency to the leaf class to feature E. And then we're going to find all the places that initialize that leaf class, feature E, and inject the dependency there. Also, don't forget to update your tests. And then step 3, we find all the places that instantiate the types that instantiate the leaf class. And we inject the dependency there. And don't forget your tests. And we repeat this over and over until we're compiling. And then step 5 is to actually do the work that you set out to do. And oh wait, after doing all that, we realized feature E is still missing some data we needed from above. So let's do it all over again. Yeah, okay. See what I mean? This gets complicated. So it's a lot of work. It's annoying. And so your clever coworker shows up and says, I've got answers. Uh-oh. Okay. The clever coworker suggests using singletons. Great. We no longer need to do any of the above work. Instead of this, we have code that looks like this. Fantastic. Right? But okay. Now we have to if let or guard let our code everywhere because all of our dependencies are optional and also probably not thread safe. And setting up your unit tests becomes an exercise of setting and unsetting static pointers. It's not simple. It's not compile time safe. It's not hierarchical. There's no easy testing. We're going to reject this approach. All right, so back to where we started. What if we avoid sharing instances entirely? Right? We've got some options here. We'll write the data to disk, and we'll use the disk for state synchronization. So if you need access to your user, just instantiate a user service and read the user object from disk. You don't need to pass the user service around. Just create a new instance when you need it. But our user object is still optional. And to make sure that multiple user service instances stay in sync, we're going to post NS notifications anytime the user is updated. And to make sure you do this all in the same thread to avoid data races, or actually, we have to make sure we do this all in the same thread to avoid data races. So we'll do this on the main queue, but we also need to make sure we're not reading and writing data to disk from the main queue. And this is getting complicated again, isn't it? So, okay, not the best approach. So let's say instead of that approach, we're going to use SwiftUI. And we're going to use the environment that comes with SwiftUI, right? So we need to add a property to the environment when it's created, and we read from the environment when we need it. Great, done, fantastic. Except that environment only works in views. So we still need manual dependency injection whenever we're using a non-view object. And then when we accidentally reuse a view in a screen that doesn't have the environment variable that we care about, we just crash. So, you know, we kind of got rid of that safety bit, didn't we there? Okay, so now we've got a new idea. Sorry, there's a lot on this slide. Bear with me. They want to use a dependency container or a scope object, for those who are familiar with the dependency injection terminology. Okay, so instead of passing around just, you know, n things, feature E needed user, it needed something else, we just pass around the scope that we need. So we're going from n to 1. Simpler. Great. But then another engineer decides to reuse that container object since it's already written, and we're now using it where it wasn't initially intended. And now we have some stateful service that has a lifecycle that no longer makes sense because remember that service is scoped to that feature, but it's now being reused in some other feature, and sadness. All right, so we can fix that. We create a new container object, dependency container object, a scope, every time we have a new dependency need, right? A new feature that needs a new scope. You're going to write fantastic documentation that everyone is going to read and understand and follow to make sure that people do this. And now you have fewer objects to pass around and life is good. Assuming everyone actually does read the documentation, because everybody always reads documentation. Am I right? I mean, sure, we have the documentation that everybody's reading. We have a bunch of custom types that are hard to explain, but this is still better than the manual dependency injection that we did earlier, right? Maybe. Ooh. Until we realize that it's super easy for us to create retain cycles by capturing self and then retaining self. Okay, so cool. We can fix that though. Great. Yeah, we can fix it. And with good documentation, it'll never happen again, right? We already covered that earlier. And so now your clever coworker thinks we've solved dependency injection. Fast forward a year, you're modularizing your code base. You need dependency inversion now to avoid creating a deep module dependency tree and avoiding circular dependencies. So you create builder closures to make this simpler. And okay, I mean, you get the idea, right? Dependency injection is really hard. It's really hard. Whatever simple tool you reach for to solve it has downsides. Anything you roll yourself is going to be a pain to maintain. Now there are some other options out there. We'll get to that. But point being, it doesn't have to be hard. I want to have you all think back to that initial example we used with manual dependency injection, right? The manual dependency injection was really easy to reason about. It did have the constructor injection, which made mocking pretty straightforward. And also, generally speaking, thread safe. The biggest problem with it was the boilerplate, right? You had to write all of this code and you didn't even know how much code you had to write to get the job done, right? It was easy to understand. It was hard to foot gun and create retain cycles, but it's difficult to maintain this boilerplate, right? And you can imagine, in fact, I'm guessing at least half the people in this room have done this. You have some dependency injection framework or system, manual or otherwise, it's hard to use. So you just, you set the static pointer because that makes life easier, right? Let's avoid all that. We might be getting some hints here on how safety is going to make your lives easier, but more on that in a minute. Before we dive into how safety makes your life better, I want to talk about dependency injection from first principles and talk about what dependency injection is doing. We're close to the meat, I promise, but there's some important background here because, again, the subject is hard. Okay, we've seen this generally before, but there's a little bit more white space. We'll figure that out in a moment. Dependencies effectively form a tree, right? Computer science tree. At each node, where a node is a view controller, coordinator, manager, or insert some other type here, we create or insert objects that we want to be available to nodes further down the tree. There are two types of objects that get inserted into a dependency tree. The first type comprises objects that instantiate themselves, given information that's already in the dependency tree. This category comprises low-level objects like networking, persistence, feature flag systems, and also higher-level objects like views and view controllers. This category could also comprise a user service with an optional user, right? The second type of the two types that can get inserted into a dependency tree are forwarded into the dependency tree from the runtime, right? This category comprises user input or network responses, right? Think about a username and password, right? You can't know about that from the dependency tree, but the user can give that to you and you can store it on disk. A canonical example is, of course, the user. And then once we have an object in the dependency tree, either instantiated or forwarded, we can receive that object at a node further down the tree. So what is the syntax I'm using? Well, it's safety. These are the three core concepts at the foundation of the compile time safe dependency injection framework safety. Safety utilizes macros to define the dependency tree. There are three macros in front of you here, just to briefly recap again, because again, this is complicated. Instantiated means that a property is created by safety when the enclosing type is instantiated. Again, more on what that means in a moment. Forwarded, runtime, created property. And received means that somebody above me instantiated or forwarded the thing, and I'm just getting it. Okay. So let's look at this in some code, because in the abstract, this is really hard to reason about, isn't it? So these macros are property decorators. These property decorators can be added to any property that is on a type decorated with the instantiable macro. Instantiable just tells safety, hey, this is a type that safety can instantiate. So these instantiable decorated types are utilized to define the dependency tree. And then safety has a build time plugin that runs to generate all of that boilerplate code for you. This is still feeling pretty abstract, I know. Let's get more concrete here. Let's walk through an example notes application. All right, so this is a simplified version of a sample application that's in the safety repository under the examples folder. This application stores a persisted to disk note per user. When we don't know a user's name, we go to the left side of the tree here, where we prompt the user to enter their name. When we have a user's name, we show them their note. It's really simple stuff. I'm gonna just play a quick video here showing what this application looks like. So actually, before I start the video, this is our name entry view. Let's watch as I log in by entering my name. You can see that username is at the top of the page, and the note I wrote last time is here. This is the note view. We log out. We log back in. Our note is still going to be there. There we go. Amazing. Now we can log in as a new user, say test, and you can see the cache note for the test user is here. And that's the whole application. Two views, name entry view and note view, and the ability to react to user changes and persist strings. Let's take a look at what this app looks like under the hood. So here we have an observable user service, which utilizes user defaults under the hood. The Notes app creates both of these types. Okay. We see the notes app here is an instantiable that is a root. It is the beginning of the tree. It is the root of the tree. That's what isRootTrue means. Let's take a look at the user service. Okay. Our user service is an instantiable decorated type. It's not a root, meaning that the user service can create itself given instances and data that is already in the dependency tree. It only has one dependency, which is user defaults, that it receives from a member-wise initializer, which you can see at the bottom. All right, pretty simple stuff. User service, user defaults, it vends a username, and when it's set, it does an object will change, right? Like pretty straightforward stuff here. Okay, in user defaults, we simply have to tell SafeDI how to create a user defaults instance. To add a third-party type to SafeDI, we declare an instantiable extension with a public static func instantiate method. And that's enough to tell SafeDI how to create this instance, or how to create an instance of this type. And here we're using a shared instance, but that's okay. Under the hood, we're still using dependency injection. Okay, so now we have an incredibly simple dependency tree. A notes app instantiates a user defaults and a user service, and the user service receives that same user defaults. But what about the views? Right? You just have a data model. We gotta actually create the application here. So let's add a name entry view to the graph, right? This is the logged out view controller or view. We see that the name entry view receives the user service that's created by the notes app. And in practice, this is really straightforward. We've got a name entry view that's an instantiable view that receives a user service. It has a text field that lets you enter your name and a login button that updates the user service with your name when you press it, right? Again, pretty straightforward. There is one thing, though, that I want to highlight on the last slide, though. I didn't say how the Notes app creates the name entry view. Instead of directly instantiating the child view, it lazily creates it when it's required. And let's, again, take a look at how this works in practice. So here's the Notes app we saw before. No changes here. You've seen this slide before. Well, let's take a look at what happens here. So we added a new property, this name entry view builder. This is an instantiated property. So we create it when the Notes app is created. And it creates, or this type is an instantiator, which means that it allows you to create the type in the brackets, the name entry view. The instantiator type is vended from the SafeDI library. It just enables lazily building a dependency. So let's take a look at how we use this thing. All we do is we call the instantiate method, which returns a new name entry view. This allows us to have a bunch of dependencies that we will create later so that we're not bloating our memory usage until we actually need to use the thing. Okay, so looking at our dependency tree, there's still something missing here. We've only got half the views we need. Let's add our note view. A little bit more complicated, but again, SafeDI's doing all the hard work for you. This view receives a user defaults and a user service instance. Let's take a look at the code. All right, so we've got our note view, which is instantiable. It's a view that forwards and displays a non-optional username, receives a user service, and receives a user defaults. When the note text is changed, the new text is written to user defaults. No, this is not performant, but that's not the point of this particular example. When the logout button is pressed, we set the username in the user service to nil. But again, I've left out a little bit of information. How did that forwarded non-optional username get there? Well, our Notes app has to send the username when it lazily instantiates the note view. And again, let's take a look at the code, what this looks like. All right, Again, you've seen this before. This is what we've seen. Lazy instantiation with, hold up. Uh-oh, went too far. One more time. There we go. So now we have an additional instantiated property. We've got the note view builder. The note view builder is again an instantiator that creates a note view. And we just pass in that forwarded property to the instantiate method, and then you're good to go, right? Any forwarded property ends up getting passed in via the instantiate method on an instantiator. Pretty simple at the call site here, really not that complex. And so now, if we look at the full dependency tree for this very simple application, each node in our dependency tree, the name entry view, the user service, the user defaults, the note view, and the notes app itself, declares what it needs, and our plugin generates the code that fulfills the tree. So what does this code look like? All right, this is a little bit nuts. Bear with me. Our build time plugin identifies the order in which our dependencies need to be satisfied, generates a no argument initializer on an extension on the root, remember is root true on Notes app, of the dependency graph. We create our user defaults. We use that to create our user service. We then create functions to satisfy our instantiator properties, and we inject all these properties into the Notes app. The plugin uses property declaration and functional scoping to enable your dependencies to be passed where they need. In a complex application, this node nests multiple levels deep, and each level is able to instantiate their own properties that are scoped to that object, and also receive properties that were instantiated multiple levels earlier in the tree. That's key, right? We can remember that original slide where we have the app, logged in view, feature A, feature C, feature E. Very easy to skip a bunch of things and just receive things at the bottom. For folks familiar with dependency injection theory, you'll notice that each node in the graph is its own scope. There is no separate scope object that you need to maintain, retain, or manage. A node's dependencies are deallocated as soon as the node in the DI tree, the instantiable type or instance, is deallocated. So again, that's a lot for folks who aren't familiar with DI theory, but just know it works the way you think it should work. That's really all there is to it. So bringing us back to that earlier example, somewhat more complicated example, you can see how safety enables you to avoid the pain commonly associated with dependency injection. Right? Following? Cool. So you might be thinking that that generated code looks pretty complex, and you really, really are hoping that you'll never have to read that code or debug it. Well, I got some good news for you. You don't need to debug the generated code. If safety detects that you've written an unsatisfiable dependency tree, we will write you a human-readable build error, and we won't generate the code. If safety detects that your instantiable decorated type is somehow incorrect, we'll write you a human-readable build error or give you a fix-it to fix the issue. It's the beauty of macros, is you can just have a little fix-it that solves all your problems. One of the really nice things about the safety plugin is that it's the first thing that runs when you hit build. It's effectively a pre-build script. So instead of needing to wait 30 seconds or whatever your local incremental build time is to see if you screwed up your dependency tree, safety will tell you if you screwed up in under a second. So looking at this again, let's say you add a new received property that wouldn't compile, like a user on feature D, because logged in view doesn't have one of those, right? And you hit build. Well, no matter how large your project is, you will get an error message less than a second later that looks like this, right? Received property user is not instantiated or forwarded in the chain app logged in view feature D. Pretty straightforward. Okay, cool. So before we move on, we have covered the very basics of safety, the 4 macros associated with it, how you build your tree, what it's doing under the hood. But we're missing some things. So you're no longer worried about having to read generated code. And you might have noticed that there were no protocols in the Notes app example I just shared. We exclusively used concrete types in that example. So you might be wondering, can safety handle protocol-oriented development? Looking at a previous example, it'd be nice if we could mock out the user defaults in the code and use a protocol instead, right? That way we could write a unit test for a user service without having to rely on disk storage, which if any of you have tried to do that before, you know will fail some percentage of the time in CI for no good reason. Since all we were using user defaults for was storing and retrieving strings, let's create a new protocol, string storage. Now let's see how user defaults instantiable implementation changes. Okay, here's what we had before. Now let's write ourselves a new protocol for string storage. Okay, cool. Simple enough. String for key, set string for key. Let's make the user defaults conform to it. Okay. We're still missing one thing though. We need to tell safety that user defaults can fulfill properties of the type string storage. All we have to do is tell safety's instantiable macro that this type, the user defaults type, also fulfills additional types. We're only including one type in this array, but this list can grow as your needs grow. So let's revisit our notes app and see what this looks like. Okay, once again, this is a slide you've seen before. No changes here. We're still instantiating our user defaults. But we wanted to change our user defaults property to be string storage. So let's do that. That's all we had to do. We changed the type name and the property name because we felt like it from user defaults to string storage. Because we've already told safety that string storage is fulfilled by the user defaults type, this just works. We'll need to do a project-wide find and replace to rename our received user defaults properties to receive the string storage property instead. But that's all we have to do to use protocols instead of concrete types. So now we understand how protocols work with safety. Cool. A few more features to walk through. The high-level point of all this is that safety can handle whatever DI needs you have, but bear with me, we're getting there. Thus far, we've created properties by instantiating them or forwarding them, and we've received those properties further down the tree. But once we have a property in the tree, is there a way for us to change its name or type? Of course there is. By now, you should know that if I ask if safety is capable of doing something, the answer is going to be yes. So let's say you have a single object that conforms to two protocols. In this case, we have a user vendor protocol that vends a user, and a user manager protocol that inherits from user vendor that vends or modifies a user. And we have an instantiable default user manager class that implements both protocols. Cool. Now let's create a logged in view that has a forwarded user that we use to instantiate a user manager object. This user manager property is backed by the default user manager we saw on the last slide, again, using fulfilling additional types from the earlier example. But what if we want to create a user vendor property and we want that to refer to the same instance as the user manager? It's really easy. It's a little bit of gobbledygook, but it's still easy. Basically, we just add some parameters to the received property. We add fulfilled by dependency name and of type. And basically what we're saying here is the user vendor is really a user manager of type user manager, and safety is just going to handle the rest. And now the user vendor is available everywhere below the logged in view. So this might look a little stringly typed, and stringly typed probably scares you, and rightfully scares you, because isn't the whole point that this is compile time safe? Well, the beautiful thing about safety and macros and build time plugins is that safety can take the string and check it at build time and make sure it's right. And if it's not right, it will write you a human readable error. You can't screw up and ship with a string here that doesn't match something real. All right, cool. Dependency inversion. I've mentioned this a few times already, and I promised you that safety supports it. But before I proved to you that safety can support dependency inversion, I want to define it because this is probably not something most people are familiar with. Dependency inversion allows one module to use a type from another module without depending on it, right? Imagine we wanted that Notes app and the name entry view to live in different modules, and we didn't want these modules to depend on one another. This can be really helpful for speeding up build times. Wide dependency tree versus a deep one, wider is more parallelizable. This isn't far-fetched. Keeping related modules from depending on each other flattens the dependency tree, right? This is something that, at least at Airbnb, we did a lot of, and I know other companies do this too. So let's go back to our Notes app. This time, if this file is in a different module than the name entry view and the Notes app can't depend on that module, how do we reference the type, right? We're still looking at the code we've seen before. So step one is we got to use a type eraser, right? We can't use name entry view anymore. So we're going to change the name entry view type to instead use an any view, right? Because the compiler, we can't reference the type because we can't depend on it. The compiler doesn't know what it is. But we still need to tell safety that we really wanted a name entry view. We do this by telling the instantiated macro to fulfill the any type with a type named name entry view. Just like with the received macro parameters earlier, we'll use a string to refer to the type, and we'll validate that at compile time. And again, if we aren't trying to create something that is real or fulfillable, we'll write you a human readable error. We also need to tell safety that we're using a concrete existential. What the heck does this mean? I'm so sorry. This is Swift in a nutshell. A concrete existential is a concrete type eraser. It's a class that erases a protocol type into an any, right? Since a view does not inherit from any view, we basically need to wrap the returned name entry view in an any view to accomplish the type erasure. It's not just a superclass, or a protocol, it's a concrete type. Because safety has visibility into your entire project and runs code generation at the root module of your dependency tree, safety's code generation can use the above macro to deliver you a name entry view in your Notes app without your Notes app module having a dependency on the name entry view module at all. Dependency inversion requires the ability to instantiate type erase properties, and given this example, we can say that safety supports this. All right, enough of safety's features. I'm hoping I've convinced you that this can solve all your problems. But any good engineer, when they're trying to adopt a new library or solve one of their problems, they're going to look at some of the competing frameworks as well. They're not just going to take my word for it. So I want to walk through some of the popular ones, and I want to just talk briefly about how they compare. The first is Needle. This is Uber's dependency injection compile time safe solution. It is honestly one of the early inspirations for this library and the work I did at Airbnb. The biggest reason, there are two big reasons I built safety instead of just using Needle. One is that Needle isn't really maintained these days. They still don't really support Swift concurrency terribly well. The other thing with Needle is that it was written before macros existed. And so in order to get the compile time safety, you have to create these scopes, these components, these like things that sit next to the things you want to do. And I don't think engineers should have to think about that kind of stuff. I think they should just say, here are the things I need, fix it. So that's Needle. The next is Weaver. Weaver is also an early inspiration for this work. Weaver was built before Needle. Weaver is still maintained as far as I can tell, which is pretty great. However, it was also built well before macros existed. And in order to define its dependency tree, it uses comments. So you just write effectively similarly like the received instantiated as comments above your properties instead of as decorators to your properties. And what this means is that you can't get fixits. All of the your errors are going to be in the build log, which isn't as nice. It's just a little harder to use. Okay, so then we have factory. We're now in a world where you still have compile time safety, but these guys don't have hierarchical dependency scoping. So remember, we had that user that was on one side of our application, right? And it was non-optional. Well, factory doesn't let you do that. You can have an optional user, but now you're no longer in this simple world of just saying, well, I have a user or I don't have a user. You're constantly writing if statements or guard statements, which I'm not a huge fan of. Similarly, Swift dependencies, which is pretty hot these days, has the same problem factory does. It doesn't have dependency scoping, hierarchical dependency scoping. You just have optionals. So again, not as much a fan. And then the last option here, which is somewhat of an OG option, it's the one that's been around for the longest, is Swinject. Swinject is not compile time safe. So there's that. It does have hierarchical dependency scoping, but without any of the compile time guarantees that safety has, or Needle or Weaver. All right, so that was a lot of information. I didn't cover everything because this was already a lot as it is. But let me just say, if you're interested in adopting safety, I really strongly checking out the README, the manual, the example projects. There is a ton of resources here with different project configuration examples to get you started. If you use CocoaPods, I've got an example for you. If you've got Swift Package Manager, I've got an example for you. If you're doing this all within an Xcode project, I've got an example for you. All the examples are there. If they're not, file an issue, I will write one for you. One thing I really do want to stress about this project is that my goal is to make safety the standard way to do dependency injection in Swift. If you adopt this library, know that I stand by it, I use it myself, and that I will help you solve whatever issues you run into during your adoption, assuming that you've read the documentation. I know we talked about that earlier. This project is 2 years old and already has adoption at multiple companies, and yours could be next. With that, I'm going to stop presenting. And if anybody has questions, I'm here for it.
Yeah, interesting thing. Thank you so much, Dan, for this incredible SafeDI. Like as Hazim said, like from the slide, everything is, you already talked about it, and yeah, I think everyone should to try. Yeah, and yeah, guys, feel free to have any question. We are listening to you. Hassan, do you have any question?
I don't have a question, but at the moment when the node view builder was added, I was saying, wow, in the background. It was amazing.
Oh, it's great to hear.
Yeah, we have, seems a good use of macros feature. Yeah, we talked, me and Hassan, wasn't you are like presenting, we talk macros everywhere. You know, this comic about the macros, this is a good use for macros feature.
Yeah, macros are really fun. There's like some compile time. So like people have seen that macros can slow down their compile time a lot because they're doing that code generation as part of your build, and that code generation is in debug if you're building debug, which is slow. One of the really nice things about safety is that I'm not doing any code generation here. I'm just doing code validation, which is pretty freaking quick. All I'm doing is making sure that you're doing things the right way, and if not, I'm giving you fixes or errors. So I've really gone out of the way here to make sure that this is performant. The build time plugin itself is also a binary that I ship so that to keep it fast, because build time plugins will build in debug, which is not great when I need to parse all of the code in your application. So if you're using that, I give you a little warning in line that says, hey, you're using the debug version, run this command on the command line, and that will fix everything for you, assuming you're using Swift Package Manager plugins. Otherwise, I've got an example that just does that automatically. So performance is a concern. Don't worry about it. I've got your back.
Yeah. There's another comment from Hazem. It's really like Hazem feeling exciting about the library is the right one, and he will. He said he will try to use. So Hazem, we are waiting for your try and your feedback.
Let me know how it goes.
Yeah. Do you have any other question? I think there's no questions.
Okay.
Yeah, for sure. If we have any question, I will like keep it and we can like send it to you.
Sounds great.
Yeah.
Also, if you have questions about the repo, feel free to file them as issues. Like, we've got open source for a reason. If I answer your question, other people will see it as well. Truly, my job is supporting y'all. So let me know.
Yeah. That's it for tonight webinar. Like, huge thank you for Dan for this fantastic session on SafeDI and the practical way and the comparison with another library. And thank you everyone who joined this live, your question and engagement support. Always like this is the key or the culture for the community. And if you enjoyed tonight's talk, like just follow us on LinkedIn and YouTube. And there's upcoming meetup this month. It will be after 2 weeks. We will like this this week. We will announce. We will do the announcement for this meetup. And yeah, thanks so much all. Thank you, Dan. Thank you, Hassan. And have a nice day. Bye bye. See you all.